Good afternoon, students. In the last class, we discussed about the preparation of haloalkanes. Okay, in today's class, we are going to discuss about the chemical properties of haloalkanes. So first, I write before going to chemical properties, I explain the physical properties. Okay, in the physical properties, solubility is there. Okay, and boiling point is there. Okay, and color is there. Okay, so due to the presence of the halogen atoms, they show the alkyl halide shows some of the colors based on the halogen atom. If Cl is there, white in color, Br is there, red or yellow, so iodine is there, violet color. Okay, like that. So based on the halogen atom, they show some colors. Okay, so if it comes to boiling point, okay, alkyl halides means that is Rx type of compounds. Okay, this is a highly electronegative atom, and R group means it must be a CH3 group or benzene group means here hydrogen will present. Okay, so here hydrogen is present. It is the highly electronegative atom means it easily forms hydrogen bond with each other. Okay, or water molecule is there, H2O. So this is a highly electronegative. This one is highly electropositive. This X forms bond with this water molecule. If any molecule which forms a hydrogen bond with the water, so that is soluble in water. If any molecule has the capacity to form a hydrogen bond with this water molecule means, yes, of course, that is soluble in water. Okay, so this is, as we know, it forms a intermolecular hydrogen bond. Inter means in between two molecules. Okay, so here is a, okay, this is highly electronegative means here, this is highly electronegative means here. X compound is there. This another hydrogen may form bond with this X. Okay, what is hydrogen bond? The force of attraction between the hydrogen and the most electronegative atom is called hydrogen bond. In halogen, in carbon, among them, the most electronegative is what? This one. Okay, so here hydrogen is there with that hydrogen. This oxygen is electronegative, they form hydrogen bond. So by the formation of this bond, they easily soluble in water. But in that, this is tertiary, okay, this is secondary, and this one is primary. I didn't wrote H here, I didn't satisfy the valency of this carbon. I simply wrote this is tertiary, this is secondary, this is primary. Primary. Next, take another example. That is CH3X, C2H5X, C3H7X. Means in the straight chain, the number of carbon atom increases like this. Correct? Here 2, 3, sorry. Here it is 1, here it is 2, here it is 3. Means number of carbon chain. So, here what happens to the boiling point means tertiary is the least boiling point, then secondary, then primary. Means tertiary alkyl halide has less boiling point and primary alkyl halides are more boiling point. They have more boiling point, they have less boiling point. Okay, next here, if we consider here, this one has less boiling point, this one has more boiling point. Okay, so students, from this in the boiling point, due to the formation of hydrogen bond, they are soluble. The solubility also follows same thing, and this boiling point also follows same thing. Okay, if this bond breaks, then the boiling point forms. When the atmospheric pressure and the vapor pressures both are equal, then the solution gets formed. Okay. So what happens to the boiling point here? Listen. Here number of carbon atom in a straight chain increases, in a parent chain increases, then boiling point increases. Here one carbon is there, here two carbon, here three carbon. Another one you take, that is butane C4H9, H9X. That is 1, 2, 3, 4. So listen, here also 4 carbon, here also 4 carbon. Here 3 carbon, here 3. Here 2 carbon, 2 carbon. Then also here the boiling point of 4 carbon is more, but here boiling point of 4 carbon is less. Correct? So what is the difference between that? Why this is more, this is less? Means listen, as the straight chain increases, the number of bonds, intervening bonds increases. Means the branch should be break here, here and here. Okay? So it takes too much time to break the bond. In the straight chain, if the number of atom increases, carbon atom increases, the boiling point increases. But here, so this is the carbon atom. At the same time, these all are identical atoms. Okay, so the bond easily breaks between these three. As the branching increases, boiling point decreases. Okay, as the parent chain increases, boiling point increases. As the branching increases, boiling point decreases. So that is the physical properties. One is solubility, they are soluble in water due to the formation of hydrogen. With respect to boiling point, here in the parent chain, if the number of atom increases, boiling point increases. In the branching increases, boiling point decreases. Okay. And next one thing, color means based on the halogen atom to which the alkyl group is bonded. Based on that, the color is important to the compounds. These are all the physical properties. The thing you have to remember is only these two. This tertiary, less than secondary, less than primary. This is important. Okay, one must there is. So next, students, the chemical properties of halogens. Okay, so if you observe the chemical properties, yeah. So now the chemical properties of this haloalkanes may be in this form or X type of compound, single bond. Next, R CH double bond, CH X type of compound. Single bond is also there, double bond is also there. Here, this is replaced by any other term, one type of reaction. Or any one term is added to this. This double bond is changes to single bond. Okay, here atom is replaced, here atom is added. That means it undergoes nucleophilic substitution reaction. Nucleophilic substitution reaction. Because X minus, the species with the minus charge is a nucleophile. So this nucleophile is replaced by other nucleophile. That's why it is nucleophilic substitution reaction. That is one type. Another one here. So addition is takes place means second one is addition reaction. Addition reaction. And the last one is reaction with metals. Reaction with metals. These are the three different types of chemical reactions which are exhibited by haloalkanes. Okay. So first we will discuss about the nucleophilic substitution reaction. So students, this is represented by the first one, nucleophilic substitution reaction. So in that height is there, SN1 and SN2. What is that? Nucleophilic substitution unimolecular reaction. That is SN, okay, nucleophilic substitution unimolecular reaction. This S stands for substitution, N stands for nucleophile, 1 stands for unimolecular. What is that unimolecular? It is a first order reaction. Means the rate of the reaction depends upon only one concentration of the reactant. Okay. So what is this reaction? So this is very important for chemistry. What I am writing here, SN1 and SN2 mechanism, among those two, any one is 100% question for examination. Either S1, SN1 or SN2. The most important is SN1. Okay. So what is this reaction? Nucleophilic substitution unimolecular. First I write student example here. I will consider tertiary butyl bromide. Tertiary butyl bromide. Okay, so this tertiary butyl bromide, when it reacts with KOH, it forms tertiary butyl alcohol. Plus this is the reaction. In tertiary butyl bromide, this reacts with KOH, alkali, forms tertiary butyl alcohol along with the KPR. This is the main reaction. Okay. But students, this reaction takes place in two steps. This reaction takes place in two steps. And right here, tertiary butyl bromide. This one is tertiary butyl alcohol. Okay. So what is this reaction? How it takes place? So this is the main reaction. You have to write here. This takes place in two steps. This reaction takes place in two steps. This reaction takes place in two steps. That is SN1 mechanism. Okay, is represented by SN1 mechanism. Okay, so that is SN1 mechanism, unimolecular substitution reaction. So in this, the first step is step 1. Okay, what is this step 1? Formation of step 1. Formation of carbocation. Okay, step 1, that is formation of carbocation. First consider this Br, CH3, CH3, CH3 gives rise to. Okay, here it forms C here, CH3, CH3, CH3 plus. Okay, students. So listen, this carbocation here it becomes a planar molecule. Carbocation, here it becomes a planar molecule. That means sp2 hybridized. This carbon is sp2 hybridized means it is a triangular shape. When it follows this structure. This is the structure. Either you want to write this, you can write it, or this. Okay, so here the formation of carbocation. How? So listen students, this is the slow step. This is the slow step and this is the rate determining step. In the before chapter I explained that if the reaction taking place in two or more steps, then the order of the reaction is explained by any one of the steps which is going to take place in a very slow manner. Okay, this is the slow step means this is the rate determining step. In this step, what is present? Only tertiary butyl bromide is present. How much butyl bromide forms carbocation, that much of product will form. Correct? How many carbocations will form from this tertiary butyl bromide, that much of product will form. That means this decides the product how much they form. Means the rate of the reaction depends upon the concentration of butyl bromide, not on this KOH. Okay, so this is the first step, formation of carbocation. This one is tertiary butyl bromide. This one is tertiary carbocation. Okay, so students, how to write the explanation here means for this SN1 step 1, tertiary butyl bromide undergoes dissociation to form stable tertiary carbocation. This is the explanation. Okay, so next one is step 2. Okay, what is that step 2? Here carbocation forming means attack of nucleophile. Attack of nucleophile. So consider this, either this or this. Okay, so I will take first one. Okay, so here nucleophile is OH minus. From here the nucleophile is what? OH minus. And the product of these CH3, CH3, CH3. Okay, so explanation you want to write nucleophile OH minus is attached to tertiary carbocation to form tertiary butanol. Right here, this is tertiary carbocation. This one is tertiary butanol. Okay, students. So listen, this may also written by using this product. How? So this much is enough. If you write this, you will get complete 3 marks. Okay. If you write this, you will get complete 3 marks. That's why I wrote everything in the board at a time. Okay. From here to here, if you wrote, you will get 3 marks. And it is compulsory question. You have to be thorough with this. Either this SN1 mechanism or SN2 mechanism. That is a compulsory. Means you know, in the examination, separate organic part will be there. The last part, fourth part. Okay. Fourth part D is there. In that, the first question 3 plus 2 it is divided. In that 3 marks question, it must be SN1 or SN2. Understand? So that's why I'm telling you. So this is all about the SN1 mechanism. What happens? SN1 means nucleophilic substitution unimolecular. Okay. Why it is called as unimolecular? This is the slow step and this is the fast step. Okay. So we do this SN1 mechanism takes place in two steps. One is the slow step, another one is fast step. The slow step is nothing but formation of carbocation. Fast step is attack of nucleophile and formation of butanol. So the slow step decides the rate of the reaction, means else in the slow step the reactant is only tertiary butyl bromide. The rate of the reaction, that is K, is directly depends on concentration of CH3 thrice Br. That's why it is called as unimolecular reaction. Understand? So here this is the balanced reaction, how it happens in a single step. Okay, actually this reaction takes place in two steps. That is called as a SN1 mechanism. Step 1 is this, step 2 is this. I hope you understand. Okay, if you write this, you will get 3 marks. Now we will discuss about SN2 mechanism. Another one I read, the reactivity of alcohols towards SN1 mechanism. That is, tertiary is more reactive towards SN1 than secondary, than primary, than alkyl. Why? Because you know in the carbocations, tertiary carbocation is highly stable. This is less stable. Okay? So due to that, the tertiary alcohols are more preferably undergoes SN1 reaction than SN2 reaction. Understand? Why SN2 reaction cannot happen? Why it forms only SN1 reaction? I will explain later. After explaining the SN2, I will explain this. Okay? This is nucleophilic substitution bimolecular. That is SN2. Okay. So this reaction takes place. Example is methyl bromide. CH3Br plus KOH gives rise to CH3OH plus KBr. Okay. Why this is called as SN2 mechanism is this rate is directly depends on concentration of this methyl bromide as well as KOH. The order is 1 plus 1, that is 2. That's why it is a bimolecular reaction. The rate is directly depends on both the concentration of the alkyl halide as well as this alkali. That's why it is a second order reaction. So it also undergoes in a mechanism, but it is a single step mechanism. Okay? SN2 mechanism. SN2. So first listen. This CH3 Br. Okay. So this is a tetrahedral initiative, correct? CH3 means here I write this one as Here it is CH3Br means I'll write it as H Br H H. Correct? Okay. Instead of that, this is tetrahedral. Okay, these four represents what? Different types. So yes, at the same time, if nucleophile attaches, okay, then what happens? This nucleophile start bonding from towards this direction, and this at the same time this Br dissociates in the same direction. Understand? Means this OH molecule is bonded from this direction. Okay? Tetrahedral shape means you move this direction. So then if you write these students, this carbon is here hydrogen, here another hydrogen, here another hydrogen. Okay? So here what happens? At the time bond breaking takes place, at the time bond making takes place. Okay? So first what happens? The OH initially attacks this methyl bromide from the back manner. Okay? In a backward direction. Okay? In the back side. So it directly attaches to what? This approaches this methyl bromide. Then what happens? This OH forms bond with this carbon. At the same time, this Br bond gets break. Okay? Simultaneously, bond making and bond breaking takes place in the same molecule. So this state is called as transition state. Okay? This state is called as transition state. Okay, so then what happens? After that, here carbon is here. This is the hydrogen. Here OH will bond. Here Br will dissociate. Okay, so students at the same time, here what happens? The Br dissociated OH is formed. Here what happens? Listen, Br is in this direction. But the attack of OH is in the opposite direction. That means what? Inversion of the configuration takes place. Correct? Here Br is here. Here OH is in the opposite direction. That means inversion of the configuration. So in the first initially what happens? Br displaces from here means here only OH attaches. Correct? That is retention. Here this is inversion because in the opposite direction OH is there. So I will explain in the chirality and isomerism in the next class. But just you remember, this is the mechanism how this methyl bromide undergoes nucleophilic substitution reaction. Understand? So at the same time, first initially in SN what happens? First carbocation will form, followed by the addition of the nucleophile. Here at the same time, the bond is formed between the other nucleophile and the bond is break between the allyl atom. Okay, so simultaneous bond breaking. This one is bond making. The state is called as what? Transition state. This is an unstable state. So after that, it forms the Br dissociate and this OH associate with this bromide carbon atom, and this one is methyl bromide. This one is methanol. And methyl alcohol. Okay, so this is SN2 mechanism. If you write this much, you will get full marks. Okay, how to write this, students? Explanation for this is methyl bromide reacts with KOH, forms intermediate state followed by dissociation of Br minus gives methyl alcohol. This is the explanation. Methyl bromide reacts with KOH, forms intermediate state followed by the dissociation of Br minus gives methyl alcohol. Okay, so if you write this one, you get full marks. So if you want to say the reactivity of the alkyl halides, means students, for this, alkyl is most preferred to reaction than primary, than secondary, than tertiary. Okay, so what is the reason for that? I'll explain. Okay, listen and focus. Okay, listen. So as I told you, the reactivity of alcohols towards SN1. SN1. Okay, that is what? Tertiary greater than secondary, greater than primary, greater than alkyl. Okay, why students? This is tertiary means I'll write here 3 carbon atoms would be there. Okay, here X. Secondary means only 2 carbon atoms. Okay, primary means only 1 carbon atom. Alkyl means only 1 carbon. The carbon bonded to only 1, carbon bonded to 2, carbon bonded to 3. Here only 1 carbon alone. So this is the order of reactivity. Why? Because SN1 is greater for this rather than this and this. Why? Because students listen. The formation of carbocation. That means one should easily form what? C plus, which easily dissociates. So here listen, all are stable CH3 groups. Okay, the CH3, 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 all are identical and all are stable. At the same time, these are electron releasing groups. Understand? These are what? Electron releasing group. This also release electron towards this, and this. That means electron density increases here. At the same time, this X group is a minus, this one is a plus. So this carbon easily donates electron towards this. As the increase in the electron releasing group increases the electron density and the carbon results in the detachment of nucleophile easily. So if more number of electron releasing group, that means what? Favors SN1 mechanism. More number of electron releasing group favors SN1 mechanism, especially in branching, not in straight chain. Not in straight chain. More number of electron here. This is the explanation. That this is the X. So in alkyl, if we take X means this is H, H and H. Okay, so if this one favors SN2 mechanism, this one favors SN1 mechanism. Why? Because students, in the SN2 mechanism, the OH minus ion attaches from backside of the molecule. Correct. So here in the backside of the molecule, so much space is there. Either any one of the side OH minus gets easily attached. So simultaneously breaking of bond, making of bond takes place. Correct? So, but here what happens? Here listen. It is already a bulkier group, a big group. Okay? It further bonded to number of atoms. Here there is no much space for the incoming of OH minus ion. If incoming OH minus comes from this side also, there is a repulsion between these molecules and these molecules. As I know, these are already stable molecules. These are bonded with what? This carbon atom. It is a stable compound. It won't break the stability. So there is no much space for the incoming OH, incoming nucleophile in the tertiary carbon atom. That's why SN2 mechanism is least in tertiary carbon, most in primary carbon. And so here another one thing is for SN2 why it is less? SN1 means this is here OH attaches from here and here. It is not that much stable. So there is no proper direction. Okay, there may be a possibility of replacement of this hydrogen by the OH group, this hydrogen by the OH group, this hydrogen by the OH group, because hydrogen is not that much stable. Understand? That's why this one is less stable for SN1 reaction. Understand? So for SN1 reaction, why it is more stable in tertiary due to the presence of electron releasing. Why it is less stable in SN1? SN2 reaction means because this there is no much space for the incoming nucleophile from the backside of the reactor. Okay, the reactivity of the SN1 mechanism is tertiary greater than secondary greater than primary, that is alkyl. Understand? So this is all about the nucleophilic substitution reactions on unimolecular and bimolecular. Okay. Next one is other nucleophilic substitution reactions. Except this one for Alexander. Another nucleophilic substitution reactions. Okay, just I write consider Rx compound and the respective products for it. So students here listen. When Rx reacts with KOH, nucleophilic substitution. How you have to find out? From here which one is X nucleophile? From here which one is nucleophile? Here X minus is the nucleophile. Here OH minus is the nucleophile. These two get interchanged. That means ROH plus KX. Okay, so I'll write here alkyl halide, alkali, this one is alcohol and salt. We will take it as salt. Okay, so by replacing this with any other group, so CH3 is methyl halide that it reacts with KOH on methanol along with Ki. You may write it like that. Okay, just I am writing the general reaction. So listen. Next, when Rx is treated with H2O, H2O how it is dissociated? H plus and OH minus. So which one is nucleophile here? Here it is H plus and OH minus. Which one is nucleophile here means? This one, OH minus. That is replaced by this X. That is ROH plus HX. Okay, so alkyl halide upon hydration or hydrolysis you may say, that is reacts with water to form alcohol and acid. Okay, next another one is RX plus KCl. RX plus KCl. They form, students, RCN compounds plus K. Here the nucleophile is Cl. Okay, so listen, here alkyl halide reacts with potassium cyanide. And right, potassium is PO potassium cyanide gives alkyl nitrites. Or you may say cyanide plus salt. Okay, so remember this one is very important reaction for 2 marks. This one and comparison with AgCl in presence of diteracetone. Okay, so here what happens, students, listen. This R compounds gives NC compounds, not Cn. If KCl is there, they give cyanides. If AgCl is there in presence of dry ether, they give NC compounds. NC means alkyl isocyanides. In the coordination compound, you already know what is this Cl, what is this NC. It means isocyanides. NC means isocyanides. Okay, and AgX, that is salt. Understand? This is the reaction. So this is these two forms what? Alcohols, and these two forms cyanide and isocyanide. This is alkyl halide silver cyanide gives alkyl isocyanides. These two comparison reactions are important for 2 marks. Okay. Next, similarly, another one is there. If RX compound reacts with AgNO2 in presence of ether or acetone. Okay, again it forms RnO2 compounds plus AgX. Okay, instead of AgNO2, if you take KnO2, okay, so it forms RONO. So here nitrogen bond is through the nitrogen atom, here bond is through the oxygen atom. This is nitrato, this is nitrito, this is nitrato. Understand? So plus AgX plus KX. Understand? So this is also important for this type of, because when this is also, listen students, when Ag and CK is there, then only that type of reactions will form. Understand? When here also KC and AgCl, here also AgNO2, KNO2. Wherever Ag is there, we are going to use ether or acetone or ethanol as a solvents. Understand? So another one is RX when it is treated with this type of compound. Which one is plus, which one is minus here? This lithium is plus, this here is minus, so it easily forms RCH3 compounds plus LNS. This is HALOALKANES. That is iron. So in all these reactions, the important thing you have to remember is always this RX compound, if it is single bond is there, It undergoes nucleophilic substitution reaction. How it undergoes? In the reacting species, you have to consider which one is the electrophile plus charge, which one is minus charge. So the species with the minus charge is replaced with this hexane. Understand? That is the thing. Is that here OH minus is there? That's why OH is replaced. Here also OH minus, so X is replaced by OH. Here Cn, so X is replaced by Cn. Here Nc, so X is replaced by Nc. Okay, na? That's Cn only, but here silver is there, so that is reverse, triisocyanate. That is mentioned. So it is dissociated as He plus and NO2 minus. NO2 is the minus means that is replaced by X. Here also NO2 minus, that means replaced by X. Here CH3 minus, that is replaced by X. The thing is, always the nucleophile is replaced by the halogen atom. This is the nucleophilic substitution reaction. Understand? So in the tomorrow's class, we will discuss about the addition reaction and also elimination reaction.